Okay, today we're going to look at graphing 3.1, but before we start the note sheet that I have for you to download, or the ones I gave you in class, I wanted to look at the basics of graphing. So when we graphed on a number line, we were graphing one-dimensional, so we just had an x-axis. But when you're graphing in two-dimension, you're going to have an xy or Cartesian plane, where the horizontal line is your x-axis, just like we were doing with the number line. And the other one is your y. The one that goes up and down is your y, and the horizontal one is your x. So if you can't remember which one's which, think about the letter y goes up and down, and x goes across. And then you have your positive numbers to the right, going on into infinity, and your negative numbers to the left. Your positive numbers go up, and your negative numbers come down. And they would continue on forever. And then you have what's called an ordered pair, which is a group that's always, the first number is always your x and the second number is your y. And so this is what's telling you directions on the plane. So if I made one up, let's say -2, 3, what this is telling you to do is go to -2 on the x-axis and +3 on the y, and when you reach both of those places, then you draw your point. So you always start at 0. So first I'm going to go -2 on the x, but I don't draw my point yet because I've still got to do what I'm supposed to do on the y, and then +3 on the y. And when you do both of those places, that's your point. That's the point, -2, 3. Okay, let's try another one. Let's say 3, -1. So for this one, I start here at the origin, or at 0, 0, and I would go over to +3 and then down to -1. And so that's the point 3, -1. And then 2 points make a line. So let me try to draw it halfway straight. So when we connect 2 points, we have a line. And there's lots of points on this line that have ordered pairs, an infinite number of points that would have ordered pairs. But we're going to look at 2 of the special points today, and that's our x and y intercepts. Let me do another one so it's a little bit. So let's say we have this line. So every well, not every line, but most of the lines are going to cross the x and y axis, giving you an x and y intercept. This is our y-axis and this is our x-axis. So where it crosses the x-axis is called our x-intercept. And where it crosses the y-axis is called our y-intercept. And so this point, you see we go over 5 and up or down 0. So that's the point 5, 0. And this one we go left or right 0, up 3. So that's the point 0, 3. Now what makes these special is these zeros. Because what's the easiest number in the world to multiply by is 0. Because 0 times anything is 0. So those are the easiest numbers to plug into formulas. So we're going to use x and y intercepts today to look at graphing. So now let's look at this note sheet. And we're going to look here at number 1. So it says graph by x and y intercepts, which means let x equal 0 and solve for y, y equals 0 and solve for x. So what that really means is when you go to graph a line, you want to make an XY chart. And back when I taught high school, they'd have like -3, -2, -1, 0, 1, 2, 3, and they'd make you plug them all in and find the y and plot your points, and it took forever. But we're gonna, now that we're in college, we want the quickest, most effective way to graph things. So we're gonna graph by x and y intercepts, because just like I showed you on this other sheet, when you have an x-intercept, your y is 0, and when you have a y-intercept, your x is 0. So the easiest numbers to pick are 0, 0. So we're going to pick 0 for x and solve for y, and then 0 for y and solve for x. Now what makes that easy is that here's our formula, x minus y equals 7. So if x is 0, that means 0 goes away. So when x is 0, you cover up x and you solve what's left here. What I have left here is negative y equals 7, or that's like a negative 1y there. So to get y by itself, I'd have to divide by negative 1. So 7 divided by negative 1 is negative 7. Or the shortcut is you're going to take this number over here and divide it with the number in front of the letter. So you're saving 7 divided by negative 1 is negative 7. Then we're going to let y equal 0. So I'm going to cover up y. I'll do this with this pen here. And that one's really easy because I just have left x equals 7. That gave me my x and y intercepts. So now I can graph them. This is like two different points. This is a point and this is a point. So for this point, I go 0 on the x and negative 7 on the y. Is that one? Whoops, one more. So I go to negative 7. And then for the second point, I go 7 on the x and 0 on the y. So 1, 2, 3, 4, 5, 6, 7. And then I go up or down 0. Or you can think, so you can also look up and down here and say x, you go to 7, y, you go to negative 7. And then 2 points make a line. So we've graphed that line by x and y intercepts. Okay, let's try another one. Again, we're graphing by x and y intercepts, so we're going to do our x, y, and our 0 and our 0. So that's how you start it, knowing we're going to plug in 0, 0. And so we're first going to say, when x is 0, do you see 0 is in the x column? I'm going to cover up the x. And you see I have left negative 2y equals 10. So I'm going to say 10 divided by negative 2 is negative 5. Then I have y is 0, so now I'm going to cover up the y, and I'm going to say 10 divided by 5 is 2. So I have the point 0, negative 5, or do you see that's negative 5 on the y? So negative 5 on the y. The point 2, 0, that's 2 on the x. 2 points make a line. Okay, let's look at this last one. Or not last one, the next one. Again, we're going to graph it by x and y intercepts. So I'm going to do my x, y, and my 0, 0. But on this one, when x is 0, you cover up your x because 3 times 0 is 0. My 0 is gone. But what I'm left with is y equals 0. Then I'm going to let y equal 0. I cover up my y, and I have 0 divided by 3 is 0. So this is a special case, and it happens when this number on the end is 0. But when you use x and y intercepts for this type, you're going to get at the same point. They're both at point 0, 0. And you have to have 2 points to make a line. You learned that back in geometry. So when this happens, which is very rarely, you just need to pick one other point. And it doesn't matter what point you pick. Most people like to pick 1 because that's the next easiest number after 0. And you're going to plug that in right here for x. So we'll do it right here. So you have 3x plus y equals 0. We're going to let x equal 1. So we get 3 times 1 plus y equals 0. Or 3 plus y equals 0. And then to solve for y, I got to move that negative 3 over and get y equals negative 3. So when x is 1, y is negative 3. So for this one, you don't have to write that, but that's the ordered pair, negative 1, 3. So I have to go 1 on the x-axis and negative 3 on the y-axis. So I'm going to start at 0 and go 1 on the x and then 1, 2, negative 3 on the y. And those 2 points make a line. Okay, let's look at the next one. Now these next two, it's just y equals negative 3. I can't do an xy chart because I don't have an x and a y, I just have a y. So when you have y equals negative 3, remember this is your y-axis and this is your x. I'm going to go to negative 3 on the y-axis and then draw a perpendicular line. You can't draw it up and down because that would be the y-axis, so you're going to draw it perpendicular to whatever your letter you're looking at. And that's all you do for those. That's the graph for y equals negative 3. x equals 6, remember this is your x-axis, I'm going to go to 1, 2, 3, 4, 5, 6 on the x-axis and draw a perpendicular line. And that's your graph. And then this next one, we've got x plus 7 equals 10. So I can't graph it until x is by itself. So for this one, I need to subtract a 7, which leaves me x equals 3. And then I go to 3 on the x-axis and draw a perpendicular line. Okay, now we're going to look at slope, which slope is always rise over run. And I usually have these up on the board, but we're going to look at slope, which is the formula for slope, which we use the letter M. M is slope, which is rise over run, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So those formulas are written right here on the worksheet. But for this part, we're just going to look at rise over run. So when we have a slope, the top number is rise and the bottom number is run. So the top number tells you how far you go up or down. You go up if it's positive, down if it's negative. And run means positive you go to the right and negative you go to the left. So when we're looking at this first, I'm sorry, I already wrote on it, but when you're looking at this first line, we want to know how far do we need to get from here to here. So you could do it two different ways. You could rise and then run. And so if we're reading it from left to right, we would rise 1, 2, 3, 4, 5, 6. So our top number would be 6, and we would run 2. So 6 divided by 2 is 3. So this has a slope of 3. But you could start at this point and read this way. If you started here, you'd go down 6. So the top number would be negative 6. You go to the left, so it's a negative 2. Oops. And then 2 negatives make a positive. So in the States, we normally read it from left to right, but you can read it right to left and get the exact same answer. You'll just have negatives. So when we look at this one, we want to get from this point to this point. I stopped the video, so let me re-explain this. So what you're trying to do on slope is you're trying to get from one point to the other without crossing through yards. So I talked about how it's kind of like Google Maps. You have a coordinate for your house and there's a coordinate for where you're driving, and Google Maps is trying to tell you how to get there by the roads that are mapped out. So, but on a graph, think of you want to get from this point to this point. You can't cut through these fences, so you've got to drive on the road. So to get from there to there, you drive down to here and then you go over there. So first you count how far you go up or down. So here I would go down 1, 2, 3, 4. So that's a negative 4. And then I would go to the right 1, 2, 3, 4, 5. So my slope is negative 4 over 5. Now if you started here and went the other way, you would go up. Whoops. We'd go from here to here, so we would go up 1, 2, 3, 4. So my top number would be positive, but then you see we'd go on to the left 1, 2, 3, 4, 5. So the bottom number would be negative. So I want you to realize that the negative can be on the top or bottom. These are exactly the same numbers. So either the negative will be out front and make it like a negative 4/5. That's the same as a negative 4 over 5, which is the same as a 4 over negative 5. The negative can be out front, it can be on top, it can be on bottom, and it all means the same thing. You just can't have two negatives, because over here, two negatives make a positive. But when you have one negative, it can be on the top, the bottom, or out front. Then let's look at these last two. These are the special cases that I really kind of just want you to memorize. I'll explain how they work both ways. But this is just flat ground, the flat table, the top of the table, and this always has a slope of 0. This is like the side of a building, and this has a slope undefined. And that's because here you would rise 0 and run any number, and 0 divided by any number is 0. So flat ground always has a slope of 0. This is like the side of a building, so here you would rise any number, but then you would run 0. So you would be dividing by 0, which you can't divide by 0. So that's why this slope is undefined. So we'll talk about this a lot later, but I do want you to memorize flat ground is 0, side of a building is undefined. And then we also want to look at what's positive and negative slope. So if you're coming from the left to right, you see on this first one we're going uphill. Uphill is a hard climb. This is a positive slope. It takes positive energy to walk up there. This one from the left to right is downhill. Downhill is a negative slope. It's much easier to walk downhill than it is uphill. This one is 0 slope. You never think about it when you're walking on flat ground. It doesn't take any effort. But the side of a building, you cannot walk down the side of the building unless you're Spider-Man. Get the wrong ones. So this is undefined. So think about what you can walk uphill as a positive slope, downhill a negative slope, flat ground is 0. You can't walk down the side of a building, so it's undefined. And like I said, we'll be talking about those later on too. Okay, this next part then is telling you to find the slope. This pushed up. But it's giving you 2 ordered pairs. And so for this one, we're going to want to use our formula. Let me see if I can get this formula in here too. We're going to use this formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You could graph them and count off just like we did this. But if you don't have graph paper, it's much easier to just use this formula. So when you're using this formula, the first ordered pair is your x1, y1, your first x and y. And this ordered pair is going to be your x2, y2, your second x and y. And if you notice here, I have what's in red is what you're going to plug in. What's in black always stays there. So always start with your division and your 2 negatives, because that's part of the formula, it never moves. And then you're going to plug in your y2, your y1, your x2, and your x1. So you start with this and then plug in the numbers, because when you have negatives, you're going to have that minus already in there. So let's see, y sub 2 is negative 2, y sub 1 is 7, x sub 2 is 1, and x sub 1 is negative 4. So do you see why it's important that I already put that negative there, because 2 minuses actually make a positive. So on the bottom, we get a 1 plus 4 is 5. And on the top, the signs are alike. Add and keep the same signs. So the slope for that one is a negative 9/5. So just start with your negatives already in there and then plug in. So let's look at this next one. This is my x1, y1, and this is my x2, y2, and I'm going to start with my division and my 2 negatives. So write that down before you even start plugging it in. And then again, we're using this formula. So y sub 2 is 4, y sub 1 is 4, x sub 2 is 2, x sub 1 is negative 5. So 2 negatives make a positive. So I get a 7 on the bottom. 4 minus 4 is 0 on the top. 0 divided by 7 is 0. So this is like a flat line, a horizontal line. This last one, again, start with your division and your 2 negatives. This is your x1, y1. This is your x2, y2. So I'm going to plug in negative 4 for y sub 2, 2 for y sub 1, 6 for x sub 2, and 6 for x sub 1. So on the top, the signs are alike. Add and keep the same sign. On the bottom, 6 minus 6 is 0. And then anything divided by 0, if you do it on a calculator, it's an error. You can't divide by 0, so that one's undefined. That's like the vertical line. Okay, just a few more. So now let's look at these last ones. So we graphed by x and y intercepts at the first part. And now we're going to graph by slope intercept. Let me move this up a little bit. So slope intercept is when you have something in this form, y equals x plus a number. When that's the case, you can use this formula and graph them just by looking at them. So let me rewrite this formula up here. So y equals mx plus b is our formula, where m is our slope and b is our y-intercept. So when we compare this to this one, this is my b and this is my slope. So b means y-intercept. Well, what that means is where it crosses the y-axis. So you do have to remember this is your y and this is your x. So this is saying go to +3 on the y-axis. So 1, 2, 3. I'm going to draw a point. So I go to +3. That's our y-intercept. Then you look at your slope. My slope is 2/3. So remember, slope means rise over run. And so from this point, not from 0, but from this point, because this is a +2, I'm going to rise 2, I'm going to go up 2, and then to the right 1, 2, 3. And once you count off your slope, 2 points make a line, so you're finished. So a positive slope is always going to go up, because it's positive, up and to the right. But let's look at this next one. So we're going to start at the back. So my y-intercept is -1. So I'm going to go to -1 on the y-axis and draw a point. But now my slope is a -2/5. So think of positive as going up. Negative tells you you're going to go down 2, but the negative is going with the top. So you're always going to go to the right on the bottom. So if it's a positive, you go up into the right, and if it's negative, you go down into the right. But when you're using this formula, you always move to the right. So I'm going to start here, and since it's a -2, I'm going to go down 2, and then I'm going to go to the right, 1, 2, 3, 4, 5. 2 points make a line. So there we go. Okay, and then this last one, it's in slope-intercept form, so this is my y-intercept and this is my slope, but it's not a fraction, and you have to have a fraction for slope. So if it's not a fraction, you just put it over 1. So my y-intercept is a +4, so I'm going to go 1, 2, 3, 4 and draw a point. And then my slope is -3/1, so the negative tells me I'm going to go down 3 and to the right 1. 2 points make a line, so we're finished. Okay, so that's 3.1. And so now the practice problems are these here at the bottom, and you can graph those and check the answers to make sure that you got them right. So you're now ready to do the practice problems on the rest of this worksheet.